We are given this equation y equals ax cubed plus bx squared. So since we are to plot y over x squared against x, we first have to arrange the equation into the form. So factorize x squared out for the left hand side. We get x squared times ax plus b. Then we divide x squared on both sides. So y over x squared equals ax plus b. Therefore, we have to plot y over x squared against x. We are given the values of x and y. However, since we need to plot y over x squared, we have to find the value of x squared. So we just square the values of x. We get 16, 25, 36, 49, and 64. And y over x squared. So we just take y divided by x squared for all values. And we get 1.125, 3, 5, 6.94, and 9.06. Then we plot the value on the graph. So we plot y over x squared against x. So this point will be 16, 1.25, 25, 3, 36, 5, 49, 6.94, and 64, 9.06. We then plot a best fit line. So this graph will be the line of y over x squared against x. Since we are to find the values of a and b, we can see from the equation that we have solved just now that a is actually the gradient and b is the y-intercept. The y-intercept can be taken from the graph where x equals 0, so it's actually this point. So when x equals 0, y equals negative 0.80, where we can see from the graph here. Therefore, b equals negative 0.800. A is actually the gradient of the graph. So to find the gradient of the graph, we have to find 2 points within the region, within the first and last point, and lines on a line on one of the intercepts. So it's easier to determine the point. So this point will be 63 and 8.90, and this point will be 15, 1.50. So to determine the gradient of the graph, it's actually y1 minus y2 divided by x1 minus x2. We let 8.90 be y1 and 1.50 be y2, 63 as x1, and 15 as x2. So when we evaluate, we get a is 1.76